Okay, so today we are going to solve this merge sorted array problem, and first we will see the brute force way and then we will optimize that one. So the question is, we have to merge two sorted array. So we have given two arrays, nums1 and nums2, and m and n are two integers representing the number of elements in the nums1 and nums2. And the final sorted array should not be returned by the function, but instead be sorted inside the array nums1. It means like we don't have to create any third array here for output. Inside the nums1 only we have to append the nums2 elements, and only the condition is that the output should be also in sorted in non-decreasing order. And to accommodate this nums2 elements, they have already given like nums1 has a length of m and n. So this array length will be like m plus n. M elements will be initialized and the remaining n elements will be 0 0 0. Like these are the elements which are already initialized and their n elements will be 0 0 0. These 0 0 0 elements we have to replace with these elements. Once we replace, then we have to make it in a sorted. So what we can do, simply we can copy all these, place it here and do arrays dot sort, but the complexity wise it's going to be n log n, because array dot sort is complexity is n log n. So that's a brute force way, or you can say it's the easiest way, but complexity wise it's not a good efficient solution. So let's first try to solve that way and then we will try to see how we can write optimized solution. So we have to copy this to this, so we have to run a loop on this, take all the elements of this. So let's say int I'll take a last element from the reverse loop I'll run, and then say I should be greater than 0, and then we'll say I minus minus, because last element will take and place it here. So placing it here we need pointer here, right? So how to get this pointer? We'll say p merge pointer merge, and size will be m plus n minus 1, right? Like it's 5, 3 plus 3 6 5. The hyper pointer will be here initially. So I'll take a value of this, and in the nums1 we have to place it, right? Nums1 p merge at the 5th position, we will take a value of I is I means nums2 I, right? We will take a value of nums2 I, place it here, and then we need to do p merge minus minus. Then our pointer will come here, and then we will take a value 5, place it here, decrease it p merge here, and then take a value of 2 and place it here. That's what is happening here in this loop. And once this is done, we are saying arrays dot sort, and then nums1. This is the easiest solution, but the complexity wise this is not a good solution. Okay, what is happening here? This is going to be a for loop. I 5 is greater than 0, that's true, and minus 1 we need to do. This is the reason. Okay, cool. It should be accepted. Submit. It should work. It's just a 2-liner code, right? But now complexity wise this is not a good. Now let's try to solve. So what we can do now, if we see closely, one and this is another input array, what we can do, we have to, so the condition is that it should be in the sorted non-decreasing order. It means the biggest element will be in the end, right? So what we can do, we'll take this element, the biggest element will be this only, right, at the end, and here in the biggest element will be at the end, right? That we know, because this is in the increasing order. So this is the biggest element here and this is the biggest element here. We can compare these two biggest elements here first, and whichever is bigger we will keep it here and move the pointer. If let's say 3 is greater than 6, no, 6 is greater, so we'll place it 6 here, and then pointer move this pointer here, and then we'll compare 3 with 5, and that way we will go. So we need one pointer p1 here, we need one pointer here, and this is a p merge pointer we needed, right, where we want to keep those elements. So let's, and with this we'll be able to solve. So we will need a p1 pointer m minus 1, and we need another pointer p2 n minus 1, and is nothing but 3 minus 1, 2 pointer will be here, this pointer will be here, and finally one more pointer we need merge, where we want to keep the values, and that will be the m plus n minus 1. Okay, now we want to run a loop. So all these elements we want to keep it here. Once this is done, then we'll come out of the loop. So we can say while p2 is greater than equal to 0. Okay, and then we can say if nums1 p1 is greater than nums2 p2, if this is greater, then we want what? We want to replace nums1 p merge at the p merge position we wanted, right? At the last position, what we want? This is greater, so we'll take this value and keep it here, right? This is what we want to replace, and we want to decrease p merge minus, and also what we want to p1 minus. Yes, now we want to replace, move p1 here, right? Else, if this is not the case, it should be in the reverse way. So what we need to do, if this is not the one, then nums1, this is going to be the same, and then what value we will replace with? Nums2 p2, right? And what we will decrease? P merge anyway will get decrease, minus will get decrease. This will get move here, right, from 6 to 5. Okay, and then this is fine. And then one more condition we need to keep it here, in case if this array is empty in any scenario. Let's p2 already we are checking here, so let's check p1 also here. P1 should be greater than 0. Let me try to run. Let's see. Okay, this is accepted. Let me submit. It should get accepted. Perfect. And this is improved version, right?
Hey, so welcome all. Today we are going to solve second problem, remove element. Yesterday we solved merge sorted array, and today we are going to solve this remove element. So what we have to do in this problem, we have given one array, nums array, and we have given a value which we have to remove from this array. So let's see the example. So this is a nums array which we have given, and value as an integer which we have given, which we have to remove from this array. And at the end we have to return a number of elements which are not equal to this 3. So if you see this 2 is not equal to 3, this 2 is not equal to 3, so our output would be 2. Similar fashion, if you see this example, we have to remove this 2, right? So if I remove this 2, and this 2, then total output would be 1, 2, 3, 4, 5. Along with that, we have to restructure array in such a way that all the elements which are not matching with this should come at front, and the remaining elements which are matching with this we have to remove with the underscore or something else. That's the ask of this question. Now let's try to solve this through brute force way, and then we will optimize it. Okay, so let me quickly first write it down what we have in the array. This is what we have given, right? And this is the element which we have to remove. What we can do simply, in the brute force way, we can run a for loop. We will remove this, we will compare this with this, and if it is matching, we will remove with a max value, integer max, right? Not matching, this is matching, max. My output would be like this. Now if I sort my array, this will look like this. So the way they wanted, now my structure, my array looks like the same way. Also they want us a counter. They want us to return number of elements which are not matching with this. So in the else condition where we are going to compare, there I'll put a counter and increase the counter. Okay, and return that counter at the end. Let's see. Let's write that code, then you will easily able to understand also. What I said, I'll run the for loop here simply. That's whatever I said, I'll do in the same manner. So I plus plus. Then I said I'll compare each element of my array with this value, and if it's matching, I'll replace my this nums I equal to with integer with max value. That's what I said. And I said at the end I'll sort my array so that my structure look like the way we want it, right? And also I said we have to return a number of elements which are not matching with this. If not matching with this means it should go into the else condition. I'll increase my counter, and this is my output. I can say output counter, pointer, whatever you want you can call it. I'm saying counter, and then at the end we have to return this counter. That's all. If I run this, this is the same thing which we discussed just now, and it's accepted. If I submit, it should get approved, accepted. It's accepted. Yeah, so this is a brute force way. Why, or you can say it's an easy solution. Only the thing is complexity here. The complexity of this whole program will be n log n. Now let's try to improve this. Let's try to optimize this. Okay. So first, let me remove this code, and okay, let's go back and try to understand how we can optimize this. So this is the input which we have given, and the output, we know that what we want 2 comma 2 comma and this dash 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 we want, or something else, right? Whatever you can say, star star something. So this is what we want. So what we are trying to say here, we are keeping all the elements which are not matching with this at the front, right? We are moving them at the front, right? So what we can do simply, we two pointer mechanism here, and using two pointer we can solve this problem. Let me tell you how. So I'll keep my one pointer here, j 0, this is 1, and this is 2, and this is 3 index, right? So j will be at this point initially. Okay, now I'll run a for loop the way we did just now. I'll compare this value with this. If it is matching, I will not do anything because I want those values at the front which are not matching. So I'll not do anything. This is matching, I'll not do anything. Now my for loop will come here in the next iteration. This is not matching. This is not matching. So I'll copy this value, keep it here at jth position. So in the second iteration, my array will become like this, right? And I'll increase my j pointer here, right? Now my third iteration loop will be here. Compare this. Oh, this is not matching. I want this at the front to here to come jth position, j1 position. I'll move it. Now my j will be here. I'll increase j also. Now I'll compare this three. Oh, it is matching. I don't have to do anything, and loop is done. And this I'll return this j at the end. My j value would be 2, and that's what I have to return, this two elements, right? And it's got restructured also because what we are leaving behind doesn't matter. That's what they have said in the question. Let me try to write this. So what we have said, we will start with one pointer j equal to 0. Similar fashion the way we did in the previous solution, we will write a loop here, nums dot length, and then I plus plus. And then we are saying we'll compare nums I with value. If it is not equal to, if it is not equal, then at jth position I'll copy my this nums I value. This is what I said, right? I'll copy this and I'll increase my pointer, and then at the end we will return j. So the complexity of this problem is going to be O of n, and this is accepted, right? This is accepted. So simply what we did, we started our pointer j, kept one pointer here, and run a for loop. We are trying to compare the values, and we are checking which values are not equal. It means you can say it's a unique value or which that's not a duplicate value, right? Those values we are shifting towards left side. That's what we wanted. And then we are increasing this counter accordingly. And then at the end, we are returning this counter. This is the solution of this problem. Thank you.
Hey, so today we are going to solve third problem, remove duplicates from sorted array. In last video, we solved remove element. Here we are going to remove duplicates from a sorted array. So we have given one array as an input from which we have to remove duplicates. And at the end, we have to return a number of elements which are not duplicate. So if you see this as an input, so this one, if I remove this duplicate, then total number of elements that are unique is 2, so the output would be 2. And also we have to restructure our array. We saw in the last problem also we restructured our array. So similarly we have to restructure also, but at the end we have to return an integer. And what is that output? That is a number of unique elements, right? Okay, so let's try to solve this. We will use the same approach, two-pointer approach we did in the last video. Same approach we will use it and try to solve this. So this is the input, let's say we have given. So what we did in the last time, we kept our one pointer j at a starting position, right? Same thing we will do it here. We'll keep a j pointer at starting position here, and we'll start comparing here. Last time we were trying to compare with the value, but here we don't have given any value which we have to compare. Here we have to remove duplicates directly from the array, right? So first we will try to compare these two values, then these two values, then these two values, then these two values. Like this we'll run a loop and try to compare, and if it is not matching, then we will shift to the j position. That's what we did. So at the end, what we know, we need output in this format, right? At the end, underscore. So what we are leaving behind doesn't matter. That's what they are saying, that all the Unix elements should come at front, right? So we have to shift all the unique elements here. So we will try to compare two elements at a time, and if it is not matching, then we will shift them at the j position, and also we will move a j accordingly. So let's say let me okay, so this is our input, right? Let me write it again. 0 0 1 1 1 2 2 3 3 4. So initially my j will be here. I'll run a for loop. I'll compare these two values. These are duplicates. I'll not do anything because I want all the unique elements at front. Now I'll compare these two. Oh, this is not matching. It means I'll shift this one here. So what I'll do, I have to shift at this position, but my j is here. So first I'll increase my j. I'll do a j plus plus first, and then at j position I'll copy this, right? Now how my array will look like, this way, right? At the second iteration, right? So on, and my j will be here now, right? My j is at this position now. Now I'll try to compare these two. Oh, this is matching. I don't have to do anything. Then I'll try to compare this to matching. I don't. I'll try to compare these two. This is not matching. Then what I'll do, I'll move this to here, right? I had to move to this to here. So first I'll increase my j. I'll first increase my j, right? I'll increase my j and then copy this to at j's position. So my output will look like, right? If you see, this is 1, this is 1, this is 2, this is 2, this is 3, this is 3, this is 4, right? And my j is at this position now, and I was comparing what? I was comparing this, right? These two. Now I'll try to compare this. Oh, this is duplicate. Then it was 3 here, it was 3, it was 4 here. Now I'll try to compare this 2 and 3. Oh, this is not matching. This is not matching means I had to copy this 3, and I have to copy where? I have to copy it jth position. So first I'll increase j, like my j will come here, and then I'll copy this to this position, so 3 will come here. This will continue, and finally at the end my array will look like this way. J will be here, and whatever we are leaving behind doesn't matter. Okay, so let me try to write a code, then you will easily able to understand. So what I said, I'll start my array from j, like first I'll put my pointer, initial pointer, like this j at 0th position, and then for loop, and start from 0, like let's start this from 1 and I, and then we'll say, I'll tell you why, I'll come to this. Then we'll say let's nums dot length, and then I plus plus. Okay, now what I said, my I will be here. So I, what we can do, we'll try to compare this and this, right? So we'll compare if nums of I is not equal to nums of I minus 1, right? Yeah, if it is not equal, then only first I'll increase my j, and then at jth position I'm copying it, right? That's what I said, I'll copy it at jth position. What I'm going to copy, I'm copying these elements, right? When I was comparing, when first I compared this two, it's matching, I leave it. Then when I compare this two, so this element I'm copying, right? This one. So first I'm trying my, so ith position I'm copying it, right? If you see, simple ith position I'm copying it here. This is what I'm doing it here, and then at the end I'll return j plus 1. Why j plus 1? So let me try to run this, we'll see. It's accepted. Now let me submit. It's accepted, right? Okay, let's try to understand why we did j plus 1 here, right? So let's try to understand with this small example. So let me copy this and paste it here, delete all content, and then okay, so if you see here, first what we are doing, we are keeping j equal to 0 here, and then comparing these two. It's matching, we will not do anything. We'll move ahead, try to compare these two. Not matching, we will shift this here, but before that we are increasing this j. So 1, then 1 2, our j will be here first, at first, and then we are copying this at the jth position, right? So 1 comma 2 comma 2, this is how our array will look like at the end, and j is it here at this position. So from here, if I return j value is 1, right? Initially it was 0, now it's 1, right? But total number of elements which are unique or not duplicates are 2, right? So we can say j plus 1. Why we are doing? Because this is zero based indexed array. So we always put plus 1, right? There are 2 elements, we'll say j plus 1, and this will give us actual output. That's the reason we have done j plus 1. Thank you.
Hey, welcome all. So today we are going to solve fourth problem, remove duplicates from sorted array part 2. In last video we saw remove duplicates from sorted array, and today we are going to solve this fourth problem. Difficulty level is medium. Let's see this question first. So so in this question we have given an input as nums array only, and one extra thing is given that each unique element appears at most twice. This is the only difference in previous question and this question. And in the output, they again want a number of elements which are not duplicate. So this is the input which is given to us. And the condition is that each number can appear maximum twice, maximum 2 times, right? So this 0 is allowed, and then this 1 is appearing 4 times, so we have to remove these 2 1s, and this 2 is allowed because this is appearing only once, and then these 3 appearing only 2 times, so this is allowed. And we have to restructure our array, so all the values which are not duplicate should come at front, and what we are leaving behind doesn't matter. And also we need output like number of elements which are unique, which are not duplicate, right? So let's try to solve this question. We can use a hash map, we can keep a frequency of each number, and that way we can solve it. But the problem is we cannot use an extra memory here. We have to modify the same array. That's the me another ask from this question. Do not allocate extra space for another array. Same array we have to restructure it. Okay, so let's try to solve this. Let's see. Let me copy this. Okay, copy this. Okay, paste this one. Okay, so let's try to see what we needed. So see what we did in the last problem. We kept one pointer here and we were comparing these two elements. So same thing we are going to do it here. We will keep one pointer j at a starting position, right? And then we will start comparing. But in this question, we need a counter as well, because we want to keep a track of numbers, because each number can appear maximum twice only. So we need a counter equal to 1. Okay. Then we will run a for loop from this place, right? Loop from I equal to 1, right? And so same array we are going to modify. Initially the value will be j will be at 0th position. J is here. Then we'll try to compare these two values. If it is matching, then counter will get increased, right? Our counter will definitely get increased. So if it is matching, I'll increase my counter. If matching, then counter will become plus plus, right? And this value I really want it. So I'll copy this value. I'll copy this value nums. So first I'll increase my j, because j is right now here. I'll keep my j here, and then I'll at nums jth position, I'll copy this, right? Ith value, I'll copy this, right? This is what. Okay, so counter become 2 when initially you compared it's matching. Counter become 2, and if maximum 2 times any value is allowed, so this is allowed. So we will copy this value and copy this value to the jth position, right? So this will become j, right? This is how my new array will look like. Means same array in a modified way. Now my loop will increase and try j is here and I is here. Now we will compare these two values. This is not matching. It means this is definitely a unique value. So we will if it is not matching, what we will do, not matching. If matching, counter plus plus. If not matching, then counter equal to 1, right? And this is unique. Definitely I want this value. So I'll link j will get increased first, then this will get copied and pasted at jth position, right? So when we are doing this condition, when counter is 1 or 2, right? So we can put this in a condition. If counter is less than equal to 2, then we are doing these two things, right? Now try to compare these two. Matching, counter will become 2 now. If counter is 2, I'll increase my j will come here, and then I'll copy this value 1 to jth position, right? Now this will get compared with this. My counter become 3. If my counter become 3 means really I don't want this one. Maximum any value allowed 2 times. So I don't want it, and if you see, it will not go in this condition also. So now what will happen? It will move further. Now this will get compared with this. Counter 4, it will get ignored. Then this will get compared with this 2. Okay, this is not matching. If counter once, then we increase first our j will come here, and then copy this value to this place. So this 2 will come here. Now you see, duplicate got removed, right? This 2 will get compared with this 3. Okay, this is not matching. This is a unique value. Counter is 1, and I'll increase my j will come here, and this 3 will get copied here, right? Now 3 will get compared with this 3. This is matching, counter becomes 2, and if counter is less than or equal to 2, I'll increase my j and copy that value to this position. What I'm leaving behind doesn't matter. My loop ends here, and my j position, whatever the j position, my j will be here. I'll return my j here. Okay, let's try to write a code. In the similar fashion, we are going to write a code. Let's see. So what I said, first we'll keep a counter j equal to 0, and then we said we'll keep a counter equal to 1. This is what we said. Then we said we'll run a for loop and nums dot length, and then I plus plus. And then what we said, if nums j value is matching with nums I value, then we will increase the counter. If it is not matching, we will not we will reset the counter. And we are saying if counter is less than equal to 2, then we are saying that increase first j and then copy ith value at jth position, right? This is what we are saying. And at the end, what we have to return, we have to return j plus 1 we have to return, right? Because this is 0 based indexed array. And this is what, let's try to run this. Oh, something I have done wrong. Oh yeah, this is fine now. Let's see. Compile time error, missing return. 1 second, let's see. Oh, this is closing it here. This is closing it here. So this is closing it here, right? I need to copy this. Yes, sorry. Accept it. Let's submit. Let's see. It should get accepted. We'll see. Yes, and it beats 100%. Thank you. Hey, welcome all. So today we are going to solve fifth problem, majority element. In the last video, we saw remove duplicates from sorted array part 2, and today we are going to solve this fifth problem. Okay, so we have given an array nums of size n and we have to return the majority element. Majority element is the element that appears more than n by 2 times. And you may assume that the majority element always exists in the array. So let's try to understand with this example 3 comma 2 comma 3. So we have given this nums array 3 comma 2 comma 3. So size of this array would be 3, and if I take n by 2 of this, it will come as 1.5, and we can say an integer, it's a 1, right? Now I'll take a frequency of 3. 3 appears 2 times and this 2 appears 1 time. Is 1 greater than this one? No. And by 2 times? No. And this 2 is greater than 1? Yes. So this 3 we have to return. So answer would be 3, right? 3 is the majority element here. We can see here also. So what we did, simply one solution, we can say that we can create a hash map, and we can keep in the hash map, we can keep a frequency of each number, and our hash map will look like this way, right? And then again, if I run a loop on that hash map and compare each frequency with this n by 2 value, and wherever I see if this frequency is greater than this, 2 is greater than this frequency 1, that time I'll return the key element, and that would be my answer. That is the one way of solving this problem. I'm not going to write a program for that one. I'll tell you why. And then another solution is going to be very easy also. It's going to be two-liner solution. And we can sort a array, and once we sort a array, it is guarantee that that majority element always exists in the array. That is what they have said in the question. So when you sort the array and if you return the mid element, that is going to be our answer. And that is just a two-liner, right? Let me quickly write it. And if I say, if I return mid element nums I 0 plus nums dot length, and if I say here one bracket divide by 2, this will solve our problem also. But the problem is that, yeah, this is accepted. If I submit, this should accept it. This is just a two-liner solution, right? But if we read the question further, the main part of the question is that could you solve the problem in a linear time? This is not in linear time because when you say arrays dot sort, complexity would be n log n, right? So this is not linear, definitely. And also they're saying that you need to solve this problem in big O of one space. If I write a hash map solution, that's the reason I said I'm not going to write a hash map solution, because if you write a hash map, it will take a extra space, right? So we have to solve this problem considering these two conditions, right? So what we can do here, we can use very famous Boyers-Murray voting algorithm, and with that algorithm, we will try to solve this problem. Okay, so we will use that voting algorithm and we will solve this problem. So let's take this example 221122. So here what we are going to do, we will use Boyers Murray voting algorithm. Okay, this is the algorithm name which we are going to use. So what input we have got it here, let's say 2 comma 2 comma 1 comma 1 comma 1 comma 2 comma 2, right? This is the input which we have got. Now initially we will assume that this 2 is the potential candidate, or just going to be major element, or going to be our winner candidate, I can say. So integer cand equal to 2, like first number, I'm saying first number will, I'll always assume that this is going to be my winner candidate. Now I'm assuming this is my winner candidate, it, and I'll keep a counter also, like this person got one vote so far, one vote, because it's a voting algorithm, so I'll talk in those terms only. So this person got one vote. Okay, this second candidate, name of the candidate is 2, and he got one vote. Okay, now I'll start a loop. I'll run a loop here from this place. Okay, now I'll compare this candidate with this winner's candidate always. If this is matching, it means this candidate got another vote, right? It means I'll increase my counter. So if, like in my first iteration, what will happen, this 2 is matching with this winner candidate, yes, it's matching, so counter will become what, counter will get increased, counter is 2 now, right? Now counter will become 2. Now iteration loop will come here, this 1 will get compared with this winner candidate, this is not matching, it means this person will lose one vote, right? If this person got 1 plus 1 vote, it means this person will lose one vote, right? Definitely from the total votes. So I'll minus from this counter. So in the second iteration, my counter will become 1. So when, if it is matching, I'll do the plus plus. And if it is not matching, I'll do the minus minus, right? Now third iteration, still the winner is candidate is 2 only, right? Now 1, I'll decrease my counter. Now if I see our array is look like this way, right? So far I have compared these values. So if you see, this is not in majority now, neither this is in majority now, right? Now counter is 0. Now if counter is 0, it means I have to write a condition. If this counter is 0, this is not, this is not winner anymore. Now this candidate I'll assume is my winner. So I'll write one condition. If counter is 0, if counter is 0, then this candidate will become a new potential candidate, and I'll set my counter equal to 1 for this one now, right? I'll set my counter to 1. Okay. Now in third iteration, I got my new candidate, and what is the candidate is 1, and for this counter equal to 1 at the end, right? Now in fourth iteration, let's see what happened in fourth iteration. Now this one will get compared with the potential candidate. Yeah, it's matching. I'll increase my counter. My counter will become 2. my counter will become 2. This 2 will get compared with the potential winner candidate, and our potential winner candidate is 1 right now. This is not matching. It means at the fifth iteration, counter will get decreased to 1. That's all, right? And still the candidate is 1 only. Now this iteration, last iteration, 2. 2 will get compared with this candidate, not matching. My counter will become 0. I mean, the last iteration, my counter will become 0. And I have said when the counter becomes 0, we are saying that we are put, 1 is not anymore a potential candidate. Who is going to be now candidate? This num, this 2, right? And I'll increase the counter. That's here. And we got our candidate. I'll return my candidate. So if you see who is the winner, 2. And if we see clearly also, 2 is the winner here. So let me try to write a code, then you will definitely able to understand. Int candidate, I can say. I said first element I'll always assume is going to win, right? Then I said he got 1 vote initially, right? Whoever it is. Then I said I'll run the loop, start from first position. That's what I said, right? Then what I said after that, we will compare this potential candidate with num's candidate. If it is matching, means he got another vote, right? So I'll increase my counter. But if it is not matching, it means indirectly he's losing 1 vote, right? Right? And I said if counter becomes 0, if counter becomes 0, that time this is not a winning candidate anymore. So my new candidate would be whatever the num's uh, position right now. And I'll increase my counter because this is my new candidate. And whatever value in the last, at the last iteration, at last position, that I'll return here. No, this is loop is ending here. Here I'll return. And this is going to be my answer. Okay, let me try to run this. Okay, this is accepted. This is accepted. So this is the voting algorithm which we used, and here we solve this problem in a linear time and also with big O of 1 space complexity. Thank you. Thanks all. Hey, welcome all. So today we are going to solve this sixth problem, rotate array. In the last video we saw majority element, and today we are going to solve this sixth problem, rotate array. This is also a very interesting problem. In this problem, we have given an integer array nums and we have to rotate the array to the right by k steps. So let's try to understand with this example. We have given one array and we have to rotate this array by k steps to the right side, right? So let me copy this and then we'll try to understand this. K equal to 3 we have given for this. Okay. So when k equal to 1, like first time when we rotate this array, so what will happen? This 7, there is no space at the end. So this 7 will come at the front, right? 7 come at the front, right? When k equal to 1. And all other values will get shifted towards right by 1 position, right? So when k equal to 1, this is how our array will look like. When k equal to 2, when k equal to 2, then this 6 will come at the front, right? This 6 will come at the front. And all these values will move towards right by 1 position, right? And when k equal to 3, this 5 will come at the front. This 5 will come at the front. And all these values will get shifted towards right by 1 position. So at the end, when k equal to 3, our output will look like this. 5, 6, 7, 1, 2, 3, 4. 5, 6, 7, 1, 2, 3, 4. So here, that's what we have to do. So let's try to solve this problem with a brute force way, and then later we will optimize it. Okay. So let's try to solve this problem, and we will use a brute force way first, and then we will optimize this. So let's try to understand with this example how we are going to solve this. So I've already copied this array here. Okay. And this array we have to rotate two times. K value is 2, which is given. Okay. Right. So what we can do initially when k equal to 1, what will happen? We'll copy this last element at the first place, right? Tell you. We will swap our last element with the first element in first iteration, right? So this is how our array will look like after first iteration. Like we are running, we need to run a loop on this whole array and take a last value and swap it with the first value. So this 99 came at the right place when k equal to 1, right? I'm talking about when k equal to 1. Now what we'll do in the next iteration, this second element we will swap with this last element. So -1 will come here and 3 will be here only. With 3 I don't have to do anything, and then -100 will come here. So this -1, if you see, when you rotate a by one position, this -1 should get shifted towards this place, and that is what is happening, right? And this 99 should come at first place. This is what is happening. Now at the third iteration, what will happen? Here, last element will get swapped with this value, right? So -100 will come here, and 3 will come here, right? So if you see, this 99 come at the front, and all these get shifted towards right side. So this is when k equal to 1, right? K equal to 1. Now if I run this loop two times, or while k is greater than 0, I'll get my output, right? So that's a brute force way, and let me write a code for this, and then definitely you will be able to understand. So what we said, we need to run a loop first, and we'll start from 0. We will run loop on this array nums dot length, right? And then I plus plus. Then what we are doing in the loop, we are copying the last element at the first position. So last element nums dot length, which position we are copying? First position we are copying. What is first position? This one, right? So when you copy, your first position will get override, right? So what I can do, we will copy this first value in temp array for the timing, right? Now this got swapped, like last position now came to this, and now this also we have to copy at the last position. So where we have to copy that? At last position, right? What we have to copy? Temp. In temp we have that first element, right? We have already copied this in the temp. Okay, so this will solve our problem. Now let's see the edge scenarios. There are some edge scenarios are there in this problem that we will take care. Well, so let me remove this one. So assume we have given one array like this, and you have to rotate k equal to 4 times. Assume it. So what will happen at when k equal to 1? This 3 will come here, this 1 will come here, 2 will come here, right? This will get shifted towards right, and this 3 will come at the front when k equal to 1. So now after once k equal to 1, this array will look like this one, right? Now when k equal to 2, this 2 will come at the front, this 3 will come here, and then this 1 will come here, right? And now k equal to 3, let's see what will happen at the k equal to 3. When k equal to 3, this will come here, and 2 will shift here, and 3 will come here. Now if you see, this array looks like same as an input array, right? So with this we can say that when you rotate when you rotate any array by n position times, then you will get an original array, right? So this array, if you rotate 3 times size of this array, then you will get the original array. So I'm not going to now rotate this array 4 times. What we can do intelligently, we can take a modulus of this, right? And if you take a modulus like k is 4 and size of this array is 3, 4 modulo of 3 is 1. So we will rotate this array one time only and we will get our output. So this is one thing which we definitely need to do in k equal to k modulo of n, right? And if k equal to 0, it means I don't have to rotate my array, right? I don't have to rotate my array. I have to simply return. Also, if size of the array, if the size of the array is less than equal to 1, that time also we have to simply return. Okay, so this is the solution. And okay, sorry, one thing I missed it. We need to run this loop k times, right? While k is greater than 0, and this here we can close, here we can say k minus minus, right? So first time 3 greater than 0, you rotate your array one time. Now k decrease to 2, 2 is greater than 0, yes, rotate your array by one position. Now k is 1, 1 is greater than 0, rotate your array. This is how we are gonna do, right? Let's try to run this and see. Oh, something is wrong. Okay, this is not n, there's num slot length, right? And similarly, oh, that's fine, this looks okay, accept it. Now let's try to submit this. Okay, so time limit, and we can see 37 test cases out of 38 got passed, and this test case is failing because due to the time limit here, k value is quite big, and so we need to optimize this one now, because the complexity wise this is n cross k, big of o, n cross k is the complexity of this problem. So we need to solve this, we need to see how we can optimize this. So in this next video we will optimize this one. Thank you. Hey, welcome all. I hope you guys are doing well. So in the last video we were solving this rotate array and we saw the brute force way, and today we are going to write, or we are going to solve this problem using some optimal approach. Okay, so in this question we have given an integer array nums and we have to rotate the array to the right by k steps. So let me directly discuss that optimal approach, because we had already discussed about this question a lot in the last video. So today I'm just going to discuss that optimal approach. So we have given input array like this, and we have to rotate this by 3 times to the right side. So in the output, we know that when you rotate this array 3 times towards the right side, output should look like this way, right? This is our output, right? So what we can do here, first we can reverse this array. If I reverse this array, my array will look like this way, right? 7, 6, 5, 4, 3, 2, 1. Now in the second step, if you see closely, this is our output. This is what we need. So if I reverse this part, I'll at least be able to solve partially. So from 0 to k minus 1, right? From 0 to 2, 0 to k minus, if I reverse, then at least I'll get my partially solved. Now if you see this closely, this is what I want, but what I have right now, this. So if I reverse again this from k to n minus 1, then I'll get my solution. 1, 2, 3, 4, and this is my solution. If you see, this is my solution. So what we have to do, we have to simply reverse this array from 0 to n, then we have to reverse array from 0 to k minus 1, and then we have to reverse the array from k to, not this, k to n minus 1. This is n minus 1, right? So 3 steps. Let me quickly write. We have to reverse the array. We have to reverse array nums as input. Will pass from 0 to n minus 1, right? So I'll say I'll pass n minus 1 here. It's fine. And then second, I said we will reverse this nums array from 0 to k minus 1. This is what I said. And third, I said I'll reverse nums to k to n minus 1, right? This is what. Now what we want first is n. So we can say int n equal to nums dot length. What else we want? We want this reverse function, right? So here we can write void reverse. What argument it is taking? Nums array, start position, and then end position. Then we know how to reverse any array. We have to simply swap first element with the last element, second element with the second last element. So we can say while start is less than end, 0 is less than end, we will simply copy last element. What is last element? We will copy this last element to first position. When you copy, before that, ensure that you create a temp variable and keep a start in some temp variable, right? And in the start position, you want, sorry, in the end position, you want this temp, right? You will copy first end to start position and this temp into the last position, right? This will simply reverse your array. Now, if you remember if you've seen the last video, we discussed some edge scenarios and that I'm going to write here that piece of code. So what we did last time, we took a modulo of this and then let's better we keep this here. And this is what we did in the last question. If you want to understand why we took a modulo, please go and watch last video. And we said if this is also n less than, this is the same condition which we used in the previous solution also. Okay. So if you see what we have done, simply this is a condition which I have already discussed in the previous video. So I would suggest please go and watch that one. And this, like I said, first we'll reverse that array completely. Then we will reverse array from 0 to k minus 1 we said, right? And then we from k to n minus 1, k to n minus 1, right? And this is how we can rotate, simply swapping the element, right? Let me try to run this. Hopefully this should work. Oh, some error. What is the error? Start and okay, this is a method signature. Here you need to pass, right? Okay, let's see now. Time limit exceed. Sorry, one thing I missed. I need to increase my this and I need to decrease this, right? This is how the algorithm works, right? Swapping the elements, accept it, submit. Yeah, it's working. All the test case are passing. Thank you. Thanks for watching this. Hey everyone. So today we are going to see this seventh problem, best time to buy and sell stock. As you know that we are solving this top interview 150 lead code questions, and so far we have solved 6 questions, and today we are going to see this seventh question. So let's first read this question and try to understand what they are asking. So in this question we have given one array prices, and we have in this array we have given a price of a given stock. Okay, so and at the end we have to return a profit, a maximum profit, by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. So we have to choose a days so intelligently so that we can return a maximum profit. So let's try to understand with this example and then we will try to solve this. This is the price of the given stock we are given. So let's say, and we have to return a maximum profit. So on any particular day we can buy stock on this given price and we can sell it on the in the future. So let's say start from the beginning. If I buy, so my initial profit will be zero, right? Now let's say if I buy this stock in 7 rupees, my buy price is this. On next day, if I sell in 1 rupees, then 1 minus 7 equal to minus 6. I'll be in the loss, right? I'll be in the loss on the second day. On the third day, if I sell, I'll be in the loss again, minus 2. Here, if I sell 3 minus 7, 4, I'll be in the loss. 6 minus 7, minus 1, I'll be in the loss. Here, I'll be in the loss. So, if I buy a stock on very first day and sell on any day, then I'll be in the loss, right? So I assumed my initially profit will be zero. If you are not able to find any profit, you have to return a zero. So what we can do, we can simply say that we will take a maximum of any day. So if 0 minus 6 on a very first day, I'll say 0 is my maximum. I'll return 0. My answer is so far 0. Here, minus 2, 0, which is maximum 0. So this way we will use maximum. This is the reason we need a maximum here. Now, coming to the second day, this is my first iteration. I'll buy this first and then sell on each day and see where I'm making a maximum profit. So I can see if I take a maximum, I'll not able to make a profit here. Definitely here, I'm making a zero profit. On the second day, now let's say if you buy this stock on 1 rupees, second day, what is your buy price now? My buy price is 1 rupees now. Now, if you sell here definitely if you sell, you cannot sell, right? On the next day in the or in the future you have to sell, right? So in the future or immediate next day, if you sell in 5 rupees, so you bought in 1 rupees and you're selling in 5 rupees, how much profit you're making? 4 rupees. So currently my maximum profit is 0. Now I'm making a profit of 4. If I use this logic, max 0 comma 4 here, definitely my answer would be 4. So far I'm making a profit of 4 rupees here, right? This is not the best case, but I'm making some profit now, at least. Now if I sell on third day, I'll make a profit of 2 rupees. Any So if I compare this 2 and 4, which is maximum? This 4 only, right? So far I am making a maximum profit is 4 rupees only. Now on this day, if I sell on fifth day, if I sell, I'll make a profit of 5 rupees. So which is maximum? This 4 or this 5? This 5 definitely. So that's the reason you need to use a max function definitely, right? And what brute force way we can do? You buy this, sell, try to sell on each day. Then buy this, try to sell on each day. Buy this, try to sell on each day. Buy this, try to sell on each day. And keep a track of maximum profit using the max function. This will solve our problem. So let's try to write the program and then hopefully you'll be able to understand. So what I'm saying, max profit initially will be 0 and I need to run a loop. 0, like I said, prices dot length, and what I'll do, I'll take my first, I'm assuming on the first day I bought this one. So you bought this one, right? On what price you bought? Let's say price is this I. Now from next day, from next day, int j equal to I plus 1. From next day, from I'll try to see where I'm making a profit, right? Where I'm making profit, that I'll see. So I have to take a maximum profit here again, this variable. Now I said I'll take a maximum always. From I'll compare this maximum profit right now. This is my maximum profit 0, comma. What is the formula for profit? Sell. Sell means current price, on the current price. Like you bought in 7 rupees, now you're selling on 1 rupees. So my current J value, right? Minus this price, right? This price, right? Now here if I return this max profit, right? If you see what we are doing it here, we are first creating a variable, assuming that on a very first day our profit is 0. Okay, then we are running a loop from here. We will take this value and try to sell on each day and keep a track of maximum profit. So let's say on very first day you bought on 7 rupees, then you are running a loop for you want to check with each days, and here you are keeping a maximum profit here in this variable, and then at the end you will return a maximum profit. This will solve our problem definitely. Let me try to run this. Oh, something's wrong. Length. Here, is it extra space? No, there's no extra space. Prices dot length. This looks okay to me. Oh, this is what is wrong, right? Let's see. Oh, something again wrong here. Yes, definitely. Accept it. Let me try to submit. Okay, so if you see 203 test cases got passed, and this is failing because time limit exceed. Reason behind it, this is not optimal solution complexity wise. So we will try to solve in a linear way. Okay, now we will see that optimal approach. So what is the input we have given? 715364. 715364. So to get a maximum profit, what we need, so somehow we need to find a day when the price is very low or minimum, right? So if you see on this day the price is very low, uh, this is the minimum price, and if I go in the future here I can see the price is very high. So if I buy on this day and sell on this day, I can make a more profit, right? So in the brute force way, what we did, how did we calculate a max profit? We used we used a max function, right, to keep a track. Here another thing, if we add simple thing, if we keep a track of minimum price also, then we can easily solve this question in a linear time complexity. So see, the simple thing is, let's say initially imagine, let's say the very first day on the very first day my maximum profit is zero, right? And what is my minimum price? Let's say on a very first day, if I buy this stock, my minimum price will be 7, right? Right now. Now this is MP, maximum profit. This is minimum price. This is minimum price and this is a maximum profit. Okay. Now I'll start a loop from this place. I'll start a loop from this place. Okay. Loop from index 1. Okay. Now on next day. So this is my second day. Now if I sell here, so on a very first day I purchased in 7 rupees, and if I sell today I'll be in the loss. How much? Minus 6. So what we did, if you remember in the brute force way, we were using a maximum function to get a profit, right? What we are doing there, max profit equal to max of previous value 0 comma current, like sell minus buy profit, right? So minus 6, and max, if I say, it will come 0, right? So max profit will come 0 at first iteration. But here also along with that, simple thing is we will keep a minimum price. What is the minimum price here? Is if I buy today, then definitely I'll be in the profit, because we'll compare this previous purchase price and today's price. What is minimum? 1. 1. So here we will use a minimum function. My previous price, this price, minimum price 7, comma current price 7 comma 1. What is minimum? 1. Now I have purchased the stock in 1 rupees. Now let's see in the future, next when the iteration come here. If I sell today on this day, I'll make a profit of 4. Now what is maximum? 0 or 4? 4, right? So 4 is my maximum profit so far. And what is minimum price? Is this 1 is minimum or this 5 is minimum? 1. So this is good, right? Because this day I will not buy. Then when it comes to this, I'll make a profit of 2, right? I'll make a profit of 2 because I have bought stock on 1 rupees. So if I sell, I'll make a profit of 2. Which is greater, 4 or 2? When I maximum profit I'll calculate, it's still 4. So it won't help me, right? And if I see the minimum, is 3 is minimum or 1 is minimum? This 1. So I'll not do anything at all on this day, neither buy neither sell. Now come to this day. Now if I sell here today, I'll get a profit of 5, which is maximum. 4, this 4 current max profit or this 5? 5. So on this day, I'll definitely sell and my profit will be 5. So my 5 profit will be 5 here now, right? And which is what is minimum here? I'll not buy on this day because still 1 is minimum. And now when it comes to 4, if I sell today, I'll make a profit of 3. But I have already got a maximum profit as a 5. So 3 I don't want. And I will not buy on this day because when I take a minimum, this 1 is still a minimum. And then here my loop ends. I'll return this max profit variable. So let me try to write the program quickly. What I said, int max profit on the very first day, I'm making a 0 profit and my minimum price will be first index. That's what I said. Quickly I'll write it. Then I said I'll run a for loop. We start with the index 1 and then n prices dot length and then I plus plus. Then I said after this I'll take a max profit. This is what we did in the brute force way also. Method.max function we used. Previous max profit, my current max profit, how to get? Sell minus buy. Sell means like the current one minus buy means what was minimum price previously. This is my buy price. And then I'll say min price also I'll maintain. Here I'll use, this is the only extra step which we need to do, and we can solve this in linear complexity min function. And then here what, which price is minimum, this one or the current price, right? That's all. That's what I said. And then return max profit. Okay, so let's see. Accept it, submit, accept it, and working. Cool, thank you. Hi all, I hope you guys are doing well. So today we are going to solve this eighth problem, best time to buy and sell stock, part 2. So in the last video we were solving best time to buy and sell stock, and today we are going to solve part 2. So let me open this question and see what they are asking. So in this question we have given one prices array, and also they are asking us to return a maximum profit. Only the difference is here they have given one extra condition. So we need to understand this extra condition, and then we will write a solution. So let's see what they're saying. On each day, you may decide to buy and or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it, then immediately sell it on the same day. Okay. So let's now try to understand this and then we will solve this question. So what input we have given? We have given 7, 1, 5, 3, 6, 4. In the previous question, we were finding the days, and here we don't have to find the days exactly, but here the condition is uh, you can buy and sell on the same day also. But if you do the if you buy and sell on the same day, we will not make any profit, right? If you buy in 7 rupees and at the evening if you sell in the 7 rupees, you will not make any profit, right? So max profit will always zero in this in that scenario, right? Max profit will always be zero. So what we can do, we can use a greedy algorithm here. We will buy and then sell, we will buy and then sell, we will buy and then sell. That way we will do. So if I buy today in 7 rupees and sell in 1 rupees, then I'll be in the loss, right? How much? Minus 6, right? Now if I buy on this day, if I buy on this day and sell on another day, like if you buy in 1 rupees and sell in 5 rupees, you will be in the profit, 4 rupees profit, right? Now third day if you buy in 5 rupees, and on fourth day if you sell in 3 rupees, you will be in the loss, right? Minus 2. And here if you buy on this day in 3 rupees, and then immediately next day if you sell, we will be in the profit of 3 rupees, right? 6 minus 3, 3. And then again if you buy in 6 rupees and sell in 4 rupees, in the loss, we will be in the loss, minus 2. So see, what we have to do, we have to calculate maximum profit we can make, and we can clearly see if we sum this, if we sum this, we will get our profit, right? 7 is the profit. So on second day if you buy, and third day if you sell, and again fourth day if you buy, and fifth day if you sell, and if you see the profit, it should be 7, right? Buy on second day, sell on third day, buy on fourth day, and sell on fifth day. And if you calculate profit and sum those profits, 7, right? And that's what we are also calculating. So it's very simple. We will use a greedy algorithm, we will run a for loop, and so but only one condition we need to apply. That's the one only condition we need to apply in this question, and we will then able to solve this. So if you see this closely, when we are making a profit, current price, when current price is less than previous price, right? Sorry, if current price is less than previous price, then you will be in the loss, right? But if current price is greater than previous price, then you are making a profit, right? When current price, like let's say it's a third day price is 5, which is greater than previous price, then you're making a profit. Like this is a current price, imagine it's 6 rupees and previous day was 3 rupees. So if current price is greater than previous day, then you're making a profit. So that's the only condition. Current day price, like price is I, if it is greater than price is I minus, if price is I minus 1, simply, then add, we will calculate a max profit and add into the max profit, right? Let me write the solution, then you will be easily able to understand. So initially our profit will be 0, okay, and initially my buy price will be on very first day, whatever the price is initially. Now I'll run a for loop, I less than prices dot length, and this is a greedy algorithm. Every day we are buying and then selling on an immediate next day. So what I'm saying, just a one condition, if current day price current day price is greater, if today's price is greater than previous day price, it means I'll make a profit, right? I'll make a profit. It now, right? How? So what current makes profit plus what is my today's price minus previous day, right? That's all. And if I return this, this is going to be my answer, right? So this is a medium difficulty level question, but if you see the solution, this is quite easy, right? Accept it, and it beats 100%. That's all. Thank you. Thanks for watching this. Hello. I hope you guys are doing well. So today we are going to see this problem jump game, and so far we have solved all these 8 problems, and you can find videos under the playlist. So let's start with this now. Let's first try to understand what is the ask here, and then we will try to solve. So we have given array, integer array, and you are initially positioned at the array's first index, and each element in the array represent your maximum jump length at that position. We have to return true if we can reach the last index. If we are not able to reach to that index, then we have to return false. So let's try to understand this with this example, and then we will try to write a solution. So example is 2 3 1 1 4. So what they are saying that if we are able to reach this position, then we have to return true. Okay, this is 0 index, this is 1 index, this is 2, this is 3, this is 4 index, right? And on each index they have given maximum jump value or integer value they have given. From this position you can make a maximum jumps. How many maximum jump we can do from this position? 2. So you can say that when you make a maximum 2 jump, you can reach to this position, right? And if you make a jump from this position, then you can reach to this. But this is a maximum jump value. You can do one thing also, like you can make a 1 jump first and then you can make a 3 jumps. That is also possible. And another is like you can make a 1 jump and from this 3 you can make another jump, and from this 1 you can make a jump and then you can make a jump, right? This is a maximum jump value they have given. So there are a lot of possibilities, like from 3 this you can make 1 jump, you can make 2 jumps as well, and you can make a 3 jumps as well. So if you use this recurring solution, then this will take a lot of time. If the value is quite big, then it's take a huge time. So we will not solve this through recurring. We will try to solve with some other way. So let's see how we can fix this or solve this in a linear way. Okay. So the thing is, हमें यहाँ तक पहुँचना है. We have to reach to this position, right? Or to this or beyond this. If you are able to reach, then we can say that कि return true करना है, right? हमें return true करना है. We have to return true if we are able to reach to this position or beyond this position. अगर हमारा reach, if our reach is greater than this last index से बड़ा है, then we have to return true, right? Return true. Now if you see this at this point, you will get to know that you can reach to this point. यहाँ हमें पता चल रहा है, right? कि यहाँ से हम 3 jump कर सकते हैं maximum. So you can reach to this point. What is the index value here? 1. And what is the actual jump you can make? 3. 1 plus 3, 4. So you can reach from this position to this fourth index, right? You can reach to last index. This is our last index. So this value is equal to this, right? ये इसके equal है. तो हम true return कर रहे हैं, right? So this is the one condition definitely we need it. But what extra we can do कि भाई हम maximum लेते हुए चलेंगे. We can take a maximum always. See, from here you can make a 2 jumps, right? So you can reach to this position, right? From here you can make a 3 jumps, you can reach to this. And from here also, if you see, you can make 1 jump only, right? You can reach to this. And from here you can reach to this. And from also you're directly able to reach. So it's better to take a maximum of these values, right? This will help us, right? So we will take a maximum reach. How far we can go from this particular place, from this index, and if we keep a maximum, that will help us. So we will always keep a maximum reach. How to calculate maximum reach? You know that. Like first we will do what thing? कि initially हम बोलेंगे भाई हमारा maximum reach तो 0 है. हम initially, और जब हम loop में होंगे तब हम बोल देंगे भाई हमारा maximum reach को हम update करेंगे. कैसे अपडेट करेंगे? हम मैक्स फंक्शन का यूज करेंगे. वी विल यूज अ मैक्स फंक्शन एंड वी विल से दैट कि भाई जो हमारा पहले वाला रीच था और जो हमारा करंट रीच है, इंडेक्स प्लस सम साई, राइट? इससे हमें पता चलता रहेगा, वी विल गेट टू नो दैट कि हम कितना दूर जा सकते हैं. और अगर हम इस इंडेक्स तक पहुंच जाते हैं किसी पॉइंट पे, इफ वी आर एबल टू रीच टू दिस इंडेक्स और इससे आगे भी चले जाते हैं, तो हमें सिंपल हम रिटर्न कर देंगे ट्रू. So these two conditions definitely we need to keep inside the for loop. Okay. Now let's see this third one more example we'll see, because we need one more condition. I'll tell you why. So मान लो अगर ये example दिया है हमारे पास, and then they are saying whether you are able to reach to this position or not. See what so far we have discussed कि हम कब पहुंच पाएंगे, when we are able to reach. That's what we have done, that's what we have calculated right so far. डिस्कस करेंगे कब हम नहीं पहुंच पाएंगे, when we will not able to reach, and that's a last condition just we need to add in our logic. So far what we have done, that let me quickly write the logic. So what we are saying that initially my max reach would be 0, that's what I said, and it's better कि अगर हम पैरेलली कोड लिखते चलें तो हमारे लिए सही रहेगा, राइट. सो लेट्स क्विकली राइट द कोड पैरेलली एज वेल. nums dot length एंड व्हाट वी आर सेइंग, हमने भाई यहाँ पे लास्ट इंडेक्स पहले ही निकाल लेते हैं हम लोग भी. लास्ट इंडेक्स निकाल लेते हैं. लास्ट इंडेक्स क्या रहेगा हमारा, nums dot length -1 लास्ट इंडेक्स रहेगा, राइट. तो हमने क्या बोला है भाई, इफ हम पहले हम मैक्सिमम रीच निकाल रहे हैं, राइट. हम मैक्सिमम रीच निकाल लेते हैं. मैक्सिमम रीच हम कैसे निकाल रहे हैं, हाउ वी आर कैलकुलेटिंग मैक्सिमम रीच, वी आर गोइंग टू यूज अ math dot max function. व्हाट इज माय करंट रीच, मैं यहाँ से कहाँ तक जा सकता हूँ, और करंट पोजीशन से मैं कितना जा सकता हूँ. करंट पोजीशन मीन्स करंट इंडेक्स प्लस वहाँ पे कितना जंप दिया हुआ है हमको, व्हाट जंप वैल्यू वी हैव गिवन, राइट. एंड देन व्हाट वी सेड कि अगर ये मेरा, इफ दिस मैक्स रीच मेरा, if my max reach is greater than or equal to last index, अगर ये मेरा max reach greater than equal to last index है, then we have to return true. This is just a positive scenario, right. हम इस point पे ही हमें पता चल जाएगा, this point, and we will return true. Now we will see the another scenario. There's one more scenario, and for that we will write a code, and that's all we have to do in this question. And end में हम बोल सकते हैं यहाँ पे एक रिटर्न फॉल्स कर सकते हैं, राइट. नाउ वी विल सी. Now see one more case. This is the case I was discussing, right? So from this is the one index 0 1 2 3. See, from here you can make a one jump from this position. So your maximum reach from this index is 1, right? 0 plus 1 1. When you come to this position, are you able to reach to this? क्योंकि मैं अभी इस इंडेक्स पे हूँ, यहाँ पे मैं यहाँ से जंप ही नहीं कर सकता. आई कांट जंप बिकॉज द वैल्यू इज 0, राइट. तो इसका मतलब हुआ कि मैं यहाँ तक नहीं पहुंच पाऊंगा, इसका मतलब मैं यहाँ तक नहीं पहुंच पाऊंगा, मुझे रिटर्न करना है फॉल्स. सो दिस इज द केस वी नीड टू हैंडल व्हेन एट सम पॉइंट वी गेट टू नो दैट कि हम भाई आगे जा ही नहीं सकते, वी कैन नॉट गो फर्दर. दिस इज द पॉइंट वेयर वी कैन सी दैट वी कैन नॉट गो फर्दर. तो हमें इमीडिएटली रिटर्न फॉल्स कर देना है इस पॉइंट पे आके. हाउ वी आर गोइंग टू डू इट, सी हमारा मैक्सिमम रीच कितना है, 1. तो मैं यहाँ तक आ सकता हूँ. अब मैं यहाँ पे आया, मैंने देखा मेरा मैक्सिमम रीच कितना होगा, करंट इंडेक्स वैल्यू, करंट इंडेक्स जंप 0, व्हाट इज द इंडेक्स 1. सो ये 1 रहेगा, तो मेरा मैक्सिमम रीच 1 ही है, राइट. आई कैन मैक्सिमम रीच इज 1 ओनली. नाउ व्हेन इट कम्स टू दिस इंडेक्स, व्हेन इट कम्स टू दिस इंडेक्स 2, मैं चेक करूंगा कि मैं यहाँ तक पहुंच पा रहा हूँ कि नहीं, वेदर आई एम एबल. हेलो एवरीवन, आई होप यू guys are doing well. Last week I was quite busy, so and I couldn't get a time to solve the lead code questions. Actually, in my organization, we are working on a new project, and that is from the scratch, and I am part of that design. So I am currently working on that architecture part. And when you work on any new project from the scratch, you need to do a lot of things, like you need to see the security stuff, how your security will look like, and also you need to identify what sort of infra you need. Also, you do the cost analysis. Let's say if you deploy something on the container Kubernetes, or something on the Lambda functions, or something on like ECS or EKS. So you do a lot of comparison there. You do see the cost analysis also, and finally you come up with the design, right? So that's the reason I was quite busy. Still, that work is in progress right now, and but today I got some time, so I thought let's continue this series. So far we have solved 9 questions. Today we are going to see this 10th problem, jump game part 2. In the previous video we were solving jump game part 1, and today we are going to see this 10th problem. If you want to see those previous 9 videos, I'll do one thing, I'll add this link into under description sections so that you can find this series. You can go through those 9 problems, and today we will try to solve this 10th problem. Okay, let's start with this jump game part 2. This is going to be similar like part 1, but here let's see what they are asking. So if you have not seen the previous video, I would recommend go and watch first that part 1, and then this one you will easily able to understand. So let's try to understand what they are asking in this question. So in this question they have given us one array as an input, and here in this array each element represent the maximum length of forward jump from index I. So we saw in the previous question also, they gave one array to us and they said for on each like this value is nothing but a maximum jump you can do from this index. In the previous question they were asking us to return true or false whether we can reach to this last index or not, but here they are not asking that one. They are asking we have to return minimum number of jumps to reach to this position. So let's try to understand this problem with example, and then we will try to write a code. So the example is 23114. So 23114. Okay, so the example is 23114, and what they are asking to reach to this index, to reach to this position, we have to count minimum number of jumps required. That's count we have to return, right? What we have to return? Count, and the end we have to return. So let's say if you start from this, if you can go to this position, right? You can make a 2 jumps, and then from here you can go to this, and then from here you can go to this. So how many jumps you did? 1, 2, 3, right? And what else you can do? You can jump, take a 1 jump from here. You can to reach to this, and from here you can again take a 1 jump. From here you can take a jump, and from here you can take a jump, right? This is another possibility. So how many? 1, 2, 3, 4. Here you're taking a count as 4. Another thing what you can do, you can go from here, you can directly jump here, right? So how many? 2. And another possibility, like you can go to this, and from here you can take a 2 jumps, and from there you can take a 1 jump. Here total count is 3, right? 1, 2, 3. And then you can at the end you can take a minimum of this, and output would be your 2, and that's your answer, right? If I see the answer of this is 2, the minimum number of jumps to reach the last index is 2. Jump one step from index 0 to 1, and then 3 steps, right? That is what they are saying. But if we go with this approach, it will take a lot of time. Like we need to write a recursion logic. We need to find all the combinations, and then we need to return minimum, right? So we are not going to write, that's not going to be efficient solution. So we'll try to solve this in a efficient way. Let's try to understand that how we can going to write a efficient solution. Okay, so let's try to solve this with this example. 3 0, and then say we have given 1, then 2, then 1 and 1. So what we have to return? We have to return a minimum number of jumps required to reach to this last index, right? So we need a count, right? Definitely, we need a count variable, and we also need maximum reach variable. If you've seen previous video, what we are calculating maximum reach, how far we can go in this array, right? And also one we are going to apply a greedy algorithm here. Like we at a very first place we assume that we can reach to this last position. So we will say we don't know what is the value here, right? So far, so here initially end will be 0. Okay, now these three things I'll initialize, and then I'll start a loop from index 0 to n minus 1. Okay, and in the loop first I'll calculate max reach. Okay, what would be my max reach? If you see in the previous video how we are calculating max reach, like current this reach 0 max function, comma, how we calculate how far we can go from this index value I plus what is the value it's given. So 0 comma I is 0th index. What is the value given? 3. So max of this is 3. So maximum reach would be 3. From here we can go till this index, right? We can go to this index, right? We can go to this index. This is maximum reach, and my count will increase because I am going to take a jump here, right? I'm going to here take a jump, right? And also, what is the how far I can go from this index? That's a what is the boundary or what is the end? My end would be the maximum reach. What is the maximum reach? So right now 3, right? Till 3 I can go, right? And I'll apply one last condition here. If this max reach, same condition we applied in the last program as well. This also we did in the last program. This also we did in the last program. If max reach is greater than equal to last index, then it means we have reached to the last index. Then here we will break the loop because we know we have reached, and at the end we will return, at the end we will return our count, whatever the count value is. Okay, but okay, so let's see, when I is equal to 1, when I equal to 1 here, what is my maximum reach value? This 3 comma index 1 plus this value 0 means 1. So my maximum reach is still 3, right? I can go till this place only. That's the maximum reach I'm saying for this array, right? But I don't want to do anything here because I'm thinking applying greedy approach. I'm saying from directly I'll go here, right? So I'll not do anything at I equal to 1. So this I don't want to execute. This I don't want to execute. And your maximum reach 3 is still 3. 3 is greater than last index. No, I don't know. I'll not break the loop. So I don't want to execute. You remember, I don't want to execute this condition. I want to execute this conditionally. We will see. Then now I is equal to 2. When I equal to 2, I'm here. My maximum reach is still going to be 3. And I don't want to do anything here. I don't want to do anything. So this will not, I don't want to execute. So when I want to execute, I want to execute this condition when I'll reach to the end of this value, right? When I is equal to end, then I just want to execute this. Now we'll see. Now my index value is now I equal to 3, right? I equal to 3, 3. And what is the value max end contains? It's 3. It's 3, right? So this will go inside this loop. It will increase the count value again. It will increase the count value. Now count will become 2. Now count will become 2, right? Now count will become 2. And from this position, what is my maximum reach now? See, if you calculate maximum reach at I equal to 3, what would be the maximum reach? Max function. Your previous reach was 3. Now current index is 3 plus what is the value given there? The value is 2. So max 3 comma 5. Your maximum reach would be 5, right? From this index, third index, I can. So I don't want to do anything here, right? So it will not go anywhere in this loop. And I got it like my maximum reach is 5 now, and 5 is greater than equal to last index. Yes, I'll break the loop. My count is 2. I'll return that count. So let me write that logic, then definitely you will be able to understand. So what we are going to do, we will initialize these values, we'll run a loop, and then we will calculate max reach. We did same thing in the last program also, and then we will put one condition when we reach to that end of that particular index, and if I equal to that end, then we will just increase the count, and if max reach is greater than last index, then we'll break. Okay, let me write that logic here, and then we'll see. So int count equal to 0 we need it, and then we need int max reach equal to 0, and then we are saying that and 0, then we are applying logic and nums dot length -1, and then we are saying I plus plus. So what we are doing, first we are calculating max reach. What is the max reach here? Max reach is how we are going to calculate. We will use a math function. Math, what is the current max reach? This is, and then to calculate how far we can go is, this is the formula, right? And then we are saying that, let me first write this logic. If max reach becomes greater than equal to at any point last index, right? What is the last index? Nums dot length -1. I'll I'll return. I'll break the loop, right? and but I have to calculate count also, right? So I said I'll increase the count always. So here I said I'll increase the count, and also I said like if I equal to when my current index will reach to the is matching with that end position, when I have reached to that end of that value, then I'll increase my count that time only, and my next end would be new max reach. Whatever max reach I've got it, that my new end will be this max reach, right? This is what I had to do. I think this is what we did, and then here we will simply return count. Okay. Okay, this is what we discussed. Let me try to run this. Hopefully this will work. Let's see. Okay, something is wrong. I've done it. This is something. This is okay. This is looks okay. Max reach we have calculated correctly, I believe. Then we are saying and okay, and this falls into this. Yeah. Let me try to submit this again. One more thing. I think this is not going to end it here. One second. This come here. Yeah. Accept it. Submit. Okay. 19.46% beats, and all test cases passed, and logic is this one only. It's a similar logic we have written, just one extra condition we have added this one. And this is a greedy algorithm where we can think that okay, from this position I can reach to the last, and then when I reach to this end, then again I'll update my end value, and again I'll jump from there. So that's how we solve this one. Thanks for watching this one.